Hui Guo from North Carolina State University. I will be presenting our paper, Caspar, Extracting and Synthesizing User Stories of Problems from App Reviews. A lot of previous studies have stressed the importance of extracting information such as feature requests and bug reports from app reviews. However, these studies typically were conducted on the review level and stopped at the identification of relevant reviews. Developers still need to read into the extracted reviews to find the information they need. We want to dig deeper into the reviews and bring the information extraction to a finer level. We have found that in app reviews, especially negative reviews, users tell stories about how they interacted with the apps. In addition to the app behaviors that are erroneous or unexpected, users also describe what they did that led to these behaviors. Take this review for the Weather Channel app as an example. Instead of only reporting that the app is pausing or not responding, the user describes the problem and the scenario where the problem occurred when I tried to scroll through cities. Automated extraction of such information is useful for developers to locate and fix the problems and improve their apps. Our goal is therefore to extract such stories from app reviews. In this study, we focus on one type of story, a mini-story of two ordered events, a user action that causes or leads to an app problem event. These two reviews are for the Fitbit app. As you can see, example 2b describes only the app problem, the app crashing and freezing, while example 2a additionally describes the user action when I go and log my food. We argue that extracting action problem pairs is more useful than collecting whole reviews that may not even help developers improve their apps. Therefore, in this study, we investigate how effectively we can extract and synthesize action problem pairs from app reviews. As a preliminary investigation, we also target a research question on event inference. Our goal is to understand the relationship between user actions and app problems. Our hope is that event inference on action problem pairs can potentially help developers prevent unseen app problems given the designed user actions. Our framework Caspar includes three parts: extraction, synthesis, and inference. We target negative reviews, specifically one-star reviews, from Apple App Store, since they are most likely to contain app problem stories. To make sure that the reviews are talking about temporary sequential events, we restrict that the targeted reviews must contain key phrases that indicate temporal relations, such as before and after. About 400,000 reviews were used. We first find the sentences that contain the key phrases, as well as the sentences surrounding them, and then use dependency parsing to extract event phrases. Here's an example of a parse tree, and two event phrases can be extracted. Based on the key phrases, we use straightforward heuristics to order the extracted event phrases. Other event phrases are kept as they appear in the text. In this example, the main event happens after the subclass event. We then classify the extracted events into user action, app problem, or neither. We used human annotators to create a training set for this classification problem. The annotators achieved moderate agreement. Here's the final distribution of event types in the annotated dataset. Note that some events were discarded as they included serious typos or grammatical errors or parsing errors. We instructed our annotators as to what event phrases should be labeled as neither or discarded. They are typically not events or not the types of events that we focus on in this study. To better understand the relationship between user actions and app problems, Caspar includes an experimental component for event inference. The problem is, given a user action, what are the probable app problems that follow it? We frame this problem as a classification problem. Given a user action and an app problem, is the latter a valid follow-up event to the former? We propose three baselines for this classification problem and compare the results. For event inference, we can rank all possible app problems by their probabilities as follow-ups and return the higher ranked ones. Since we only have positive data to train such a classifier, we use negative sampling. which is simply to use random events as negative data. Please refer to our paper for details. Caspar achieved good accuracy in classifying event phrases based on their types. Here are the classification results for the aforementioned events. Based on the classification of the events and their temporal orders, we can synthesize the action problem pairs. In the end, we collected about 85,000 such pairs. As you can see, in addition to the problems, these results also include when these problems happened, which provides more information for the developers to fix them. We then compared the extraction performance of Caspar against human annotators in a small scale. Caspar achieved high precision for the extraction against humans, but relatively low recall, which we discussed later. We trained the classifiers for event follow-up classification based on the extracted action problem pairs, as well as negative samples generated by different strategies. The classification can achieve moderate accuracy. For event inference, as an example, we ranked all possible app problems by their probabilities as follow-ups to the user action "I try to screw two cities," and retrieved the top 10 problems. According to our annotators, 5 of them are plausible, 2 receive conflicting judgments, and 3 are not relevant. As we discussed, the extracted action problem pairs include richer information and are easier to understand than problems only. Inferring events can help developers better understand the relationship between user actions and app problems. However, Caspar has its limitations. For example, we used key phrases to make sure that the events are temporally related, but they also cause Caspar to have low recall, since only a relatively small portion of the reviews contained such key phrases. Also, parser-based extraction may not be as reliable when it comes to user-generated text, that is, full of typos and grammatical errors. User stories can be more complicated than 2 events. The review in this example contains a story with a longer sequence of events. And events like reset my phone can be ambiguous without context for event type classification. Future work includes improving the precision and recall of event extraction, investigating stories longer than 2 events, and improving event inference performance. Thank you.